I'm going to use the words that other people use for this. So, works out, whatever. Or, no, I know, I'll just use point, line, square, cube, etc. Like, a line goes out to infinite, whatever, but I'm just meaning a line. As long as we're all on the same page for language. So we start out with point of 0 dimensions. How do we get the next one? We take one of these and move it. So, or easy way to think of it as you draw 2 of them and then connect them. So 1, 2, connected. We know how many dimensions are on top. So 0, 1. How do you draw the next thing? Oh, well, I'll draw 2 of these and connect them. Oh my god, it's a square. And then the next thing, so, things that they've grown up with. So, wait, this 4-dimensional thing that I was trying to draw before, it's not just, so, I'll follow the same algorithm. So, I'll draw 2 of these. And, draw 2 of these, Okay, now I draw another one. And then connect all the corresponding points. This one goes to here, this one goes to here. It looks a lot better if you have to, put them close enough together. You have to, make sure that you aren't going at an angle that you've gone before, and, they're fun to draw. I usually use different colors to distinguish between the different dimensions. And then, of course, the next thing would be take this and move it. So I spent a lot of time drawing these and getting all the lines together. A lot of times I would have to use a straight edge to make sure that it doesn't that I don't lose track. It's so easy to lose track, especially when you get as high as 5 or 6 dimensions. So, I think it was last year, the year before, I came up with an easier way of drawing these things, or at least representing them. So, there's not really many ways to represent it. So, here, I don't know, I'll start here, because here is where you really need it, and then I'll project it back. So this, I drew 2 cubes, and then I just connected all the lines together. So how about just for shorthand, I just draw 1 line. You know what it means, I know what it means. That'll just be the way that we draw it. Oh, cube, and cube, connected with a line. This is a 4 cube, I declare. And a 5 cube, because the way that I ended up drawing a 5 cube was drew a cube, and I drew a cube, and I connected those ones, and then drew a cube, and I connected those ones, and I connected all of those. That kind of looks like a square of cubes. So, am I running out of room? It's okay. So square, or cube, 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 and a square of those. And then, of course, a 6 cube would be a cube of cubes. What's the logic to that? I know, it's you add up how many things there are. So this is a 3 plus a 2 thing to make a 5 thing. This is a 3 plus a 1 to make a 4. And then you can split them up different ways, too. So this one, 4 cube could be a square of squares. And this could be a cube of squares, It could be a square of cubes or a cube of squares. And then, so here, this would be a square of lines, it could be. Or it could be a line of squares. Draw 2 squares and connect them. So what is this thing that I draw here? Well, this could be a point, and for every point, you draw a cube. So there's only one, so I draw a cube. Or it could be a cube of points. And so on and so forth. And so this gets us back to why I saw how the little one-dimensional block that I had in elementary school looked so much like that bigger 10 by 10 by 10 cube. Because it is. It's someone called it a blow up. So here I draw a square, except at every point, instead of thinking of it as a square, there's a little cube there. And then that's how we can think of bigger things instead of a big old thing. So my next question after this was, so section 2. My next question after this was, so this has a point, this has 2 points, this has 4 points, and then 8, and then 32, okay, and then how many edges does each one have? How many faces? How many 3 faces? So I made a really long chart of, okay, so all the points, they get doubled each time because you draw 2 of them and then connect them. So edges, so an edge would have to, for each edge, it gets doubled. Then you connect them all by the number of points. So the way that you ask how many faces, for example, n cube has, it would have 2 times however many faces the other one had, like right before it, so n minus 1. 2 times, wait, the, write it down. Faces of n cube. I take 2 times faces of n minus 1 cube, and then 1 times the edges, not lines, edges, of the n minus 1 cube. And this same, since that was an expansion of the pattern from the last, from like points and edges. This one's faces and edges. And it's all for the same reason, because you draw 2 of them and then connect them. So here, so each point became a line, and then each line stretched out and became a face. And so I used that to chart it, and then also the idea that there's 1 face of this, and then 2 faces of this, and then 1 edge here, and 1 point here, things like that. So I made a huge, huge chart, and then I figured out all the ratios between them and figured out the pattern there, and because what I really wanted was an explicit formula for how many K faces an N cube had. I went to one of my professors and I was like, I found this pattern, what do I do with it? And it was something, I really don't remember what it is. I mean, if you go back and check, it was something like, N choose K to the N, or something. So like the 2 to the times 2, times 2, times 2, times 2, times 2, 2, 2, 2. And then this I had never seen before. I had never seen choose. And it was the blossoming of my God, discrete math exists. It was amazing. And now I'm taking discrete math